All right, so it says give the equations of any vertical, horizontal, or oblique asymptotes for the graph of the rational function. So we have, let's rewrite this as f of x equals negative 2x plus 4 over 4x plus 4. I just wanted to have the terms from degree least to greatest, right? And now I also will factor out some stuff and cancel. I'm going to put this in lowest terms. So I have negative 2 times x plus 2. I'm factoring out the negative 2. This needs to change to a negative 2 though. And then in the bottom, I can factor out a positive 4. And then the 2 goes into 4 evenly. Right, so now I have negative x minus 2 over 2 times x plus 1. So that means that I have a vertical asymptote at x equals negative 1 and a horizontal asymptote, let's see. To see the horizontal asymptote, let me simplify this just a little bit more. So I have negative x plus 2, I'm just distributing that negative, and then 2x plus 2. And since the degree of the numerator is the same degree as the denominator, my horizontal asymptote will be at y equals negative 1/2. And that's because the lead coefficient of the top is negative 1 and the lead coefficient of the bottom is 2. Select the correct choice below, and if necessary, fill in the answer box to complete your choice. The equation of the oblique asymptote is y equals something. Well, no, because we have a horizontal asymptote, there will not be an oblique. It's either one or the other. Number 10, give the equations of any vertical, horizontal, or oblique asymptotes. So once again, can anything be factored here? Not really. So if I were to factor the top, I could factor it to x minus the square root of 3 and x plus the square root of 3 because it's the difference of squares. But that would not help me cancel anything out, so I'm not going to do that. And looking at the denominator, I can't let x be negative 4. So there's a vertical asymptote at x equals negative 4. The degree of the numerator is greater than the degree of the denominator. And in fact, they're different by 1, which means that I have an oblique asymptote instead of a horizontal. Remember, oblique basically means slanted. Now to figure out what that is, the equation of it, I'm going to do division. Now in the previous example where I showed how to find the equation of an oblique asymptote, I used long division. I could have also used synthetic division, I just didn't, because I wanted to review long division since that will be on the test. However, synthetic division is also going to be on the test, and it is useful when you have a divisor that is linear like this one is. So I'm going to employ synthetic division this time, starting to set it up with a negative 4 on the outside, so that's the 0. And the coefficients of the polynomial I'm dividing, making sure that the degree of the terms go in descending order, and also that I don't skip any. So I have a coefficient of 1 on the x squared term. There's no x term, so I'm going to put 0 as the coefficient, and then the constant term. So I'll drop down the 1 as my first step. Multiply -4 times 1 is -4. -4 times -4 is 16, leaving me a remainder of 13. So the remainder is 13. So if I was, where we learned how to use synthetic division before, we were looking to see if the denominator would divide evenly into the numerator, and that would be if you had a remainder of 0. But that's not the application we're looking for here. In this case, we don't care about the remainder at all. And so we only wanted to know what is the equation of the oblique asymptote, which is the part that's not the remainder, 1 degree less than the original polynomial we were dividing. So since the original polynomial was degree 2, I'm going to create a new polynomial of degree 1 using these coefficients. So the oblique asymptote has the equation y equals 1x, or just x, minus 4.